Hey everyone, have you ever seen a metal lid pop of a jar after running it under hot water? That's thermal expansion in action. In this lesson, we're diving into the coefficient of thermal expansion and the coefficient of volume expansion, fancy terms that explain how heat makes materials grow or shrink. Get ready to discover how temperature changes affect everything around us, from bridges to balloons. Let's jump in. Objective: define coefficient of thermal expansion and coefficient of volume expansion. Thermal expansion. The coefficient of thermal expansion describes how the size of an object changes with a change in temperature. Especially, it measures the fractional change in size per degree change in temperature at a constant pressure, such that lower coefficients describe lower propensity for change in size. Here is the formula of linear or thermal expansion. Here are some examples of linear or thermal expansion. Problem: a steel rod has an original length of 2 meters at 20 degrees Celsius. If it is heated to 70 degrees Celsius, how much will its length increase? The coefficient of linear expansion for steel is equals 1.2 x 10 to the power of negative 5 plus degree Celsius. Solution. Here are the given of the problem. Using the formula, let's substitute 2 times 1.2 x 10 to the power of 5 times 50. The answer is delta L equals 0.0012 meter. Final answer is the road will expand by 0.0012 meters or 1.2 millimeters. So, when the temperature increases, the steel rod gets slightly longer, about 1.2 millimeters. That may seem small, but in large structures like bridges or railways, thermal expansion can make a big difference. Volume expansion. The degree of volume expansion divided by the change in temperature is known as the coefficient of volume. It is symbolized by the letter of. It is a feature of the substance. It varies based on the temperature. Here is the formula of volume expansion. Delta V equals V0 or Y delta D. Here's the example of volume expansion. Problem: a glass container has a volume of 500 ml at 25 degrees Celsius. It is filled with water and then heated to 75 degrees Celsius. If the coefficient of volume expansion for water is equals 2.1 x 10 to the power of negative 4 plus degrees Celsius, find the increase in volume of the water. Solution. Given. Let's substitute 500 times 2.1 x 10 to the power of negative 4 times 50. The answer is 5.25 ml. So, the water's volume increases by 5.25 ml when heated from 25 degrees Celsius to 75 degrees Celsius. So, as the temperature rises, the water expands by about 5.25 millimeters. This is why we should never fill containers completely. The liquid can overflow when heated. In summary, the key takeaway is that the coefficient of volume expansion is a specific type of coefficient of thermal expansion. The general term coefficient of thermal expansion can refer to linear area or volume, but coefficient of volume expansion precisely defines the relative change in volume with temperature. Thank you for listening. Bye.